Quick introduction, Brad Goodman.
Senior architect at Dell. He's the co-chair of the FIDO working group, very active in the development of V1.2 with Jeff. And the next section is to talk about FIDO bare metal onboard. So as we said in the kind of keynote this morning, FDO can be part of a very interesting opportunity to trigger the deployment of operating systems and applications or containers or VMs. And Brad will walk you through. And again, this is a conversation, so don't hesitate to interrupt him if there's something you either don't fully grok or just frankly disagree with. So with that, I'm just going to, there you go. So Brad, if you're ready to go, I'll move you on.
I am, and that was Richard's way of saying I talk too much. So feel free to interrupt me if need be. So I will say, yeah. So I'm an architect with Dell, and I work on principally on edge and security and FDO, and am actually involved with and responsible for the evaluation and looking at some of the ARM-based technologies that we now might want to apply to. We have a product called Native Edge. And right now, everything we ship is x86 based, but looking to include ARM systems in the portfolio. It's very high secure. It's FDO based, and a lot of the security on the platform is rooted by FDO, which is really important. As Jeff talks about certificates and credentialing, using FDO as this anchor of trust. And I will also say that in my night job, I am a member of a makerspace here in Nashua, New Hampshire, and part of my large responsibilities is around sort of the IT and the infrastructure of things that go on in our lab, including a giant prolifia portfolio, whatever you want to call it, of ARM single-based computers that we use for everything from access control to digital lighting, signage, even vending machines. So a really good, I think, representation of a lot of the things that ARM-based systems are used in real world in sort of more, kind of embedded edge, kind of, not really embedded, but more edge type of things. So being responsible for distribution, upgrades, development, all that stuff, initial deployment, management of those ARM-based SBCs and all these real edge-based locations is sort of interesting because it, in my night job, gives me a good amount of visibility into some of the things that people are doing and the things that I tackle in my day job. Anyways, as Richard and Jeff probably elegantly described, FDO is really a system to introduce an endpoint and a control plane or an owner together so they mutually understand that they belong together, so that then they can provide secret credentials and interoperate forever after. And in the space of regular IoT devices, that makes a lot of sense. If I'm a light bulb and I have a light bulb control plane and I want to know that these two things can go together so that now my control plane can control that light bulb, we understand that use case. But now, as we, Dell, and other players move from these embedded systems into more higher end systems, edge-based systems, which are leveraging single board computers in that, there's always this thing of, so this late binding aspect of what FDO allows, which is the fact that I can introduce an endpoint in a control plane which have not been pre-established in the factory that they belong together, but I can late bind, I can determine after manufacturing how these things go together. That's really important. But in the world of single board computers, which are not IoT systems, this means that unlike this IoT light bulb, which had all this firmware on here to be a light bulb, if we want to really apply this concept of late binding to single board computers, that means we might not necessarily know what this single board computer, what the application is going to be, let alone the owner. So the idea of we want to apply this concept of late binding after the manufacturing process to general purpose computers implies the subject of this, which is the need for some sort of bare metal onboarding. And I will say, from a personal perspective, we went to kind of summarily tackle this and said this can't be very difficult. There's a million different ways of doing it. We do this at Dell with things like we have something called BIOS Connect. We can hold down a bunch of magical keys on boot and it'll re-image your system from the cloud. Apple does a similar recovery thing. So we said there must be a million different ways that we can do. And VMs, we have the ability to use things like Kickstart and Cloud Init to pull a standard distro for something and slap it on something and apply a configuration and have a VM. So we looked at all this stuff and said this can't really be that difficult to do ubiquitously across a bunch of different operating systems, even on x86 systems, let alone on ARM systems. And so, we went off and we did a very extensive look at what the state of the art is. And this slide right here kind of is my encapsulation of what I believe the state of the art of everything is today in terms of doing this. And the good news is there's a bunch of ways to do it, and they work in a lot of situations. The bad news is there's no one single solution here that works in all situations. Some work in virtual environments, some work in physical environments, some require things like physical media mounts to specify, if not your installer image, your configuration things, or if you're in a VM environment, a virtual media mount that can do that, or requires custom user intervention to basically manually apply configuration changes, or custom image creators, which I think, for example, Raspberry Pi Imager, or I think OpenShift works like this, where you can say, here's my base image, and the IT person or whatever it puts in the parameters that they want. They get baked into the base image, and that base image is specific to that machine that's going out there. But in general, most systems, and not all systems, but certainly most x86 systems have some sort of firmware that's baked into them, PXE, iPXE, or even the ability to do USB boot, and that's kind of in system firmware. And there is ample stuff out there to allow those boot systems to be given or pull down an ISO file or an EFI installer, and to be able to run that or apply that to a disk, and you get as the net result a installation image which is on that system. So these kind of things in the center right here show that, kind of the standard things that a platform provides, the standard things that any OS distribution would apply, and put those two together and you wind up with an installed system. How configuration data to customize in any way those systems are applied is sort of another thing. I can use Kickstart, I can use Cloud Init, there's a whole bunch of different ways, but they require things like as I said, virtual media mounts, physical media mounts, maybe a USB key, maybe a virtual media mount that can be applied. If I have at Dell, we have something called iDRAC, which is our BMC, and it's this, I don't want to say expensive, but it's a heavyweight way of saying, yeah, I can put a Kickstart file and I can create a virtual media mount and I can apply that to the system so that when we remotely do this, it sees our configuration on there. Well, that requires a BMC to do this. So, the long story short of it is there is no one solution that can work for physical machines, not virtual machines, unattended, without requiring specialized hardware like a physical media mount, virtual media mount, BMC to present one of those, or things to have to inject things like kernel command lines, which require network or user intervention to specify this, and will work across all the operating systems. So this is kind of the problem statement that I believe we at Dell, and probably anybody else that's working, we can do this in virtual machines because we have the ability to kind of fake some of the virtual hardware, but it's very hard to do this, and to do this in a way that works across all the things. So given that, FDO, we do bare metal onboarding. Sorry, we do device onboarding. And device onboarding applies this concept of late binding a device so it can talk to the control plane. And when people look at that and then they go back to these new compute platforms, or general purpose compute platforms, they say, well, wait a minute. Now I can late bind credentials and I can late bind the identity between an endpoint and an owner, which is fantastic. But what about that concept of the software, the stuff that runs on there? So that's something we are organically, actually go back one slide quick. We are organically, tasked to solve here. So why do we want to solve it? And so the short ability is, if you look at FDO's core capability, we have the ability to to manufacture that device and to late bind the concept of who the owner is. So forgetting for a second the specific protocols TO0, TO1, and TO2, FDO has a core capability of being able to introduce an endpoint to who its owner is in a late bind manner after it leaves the factory. So go on to the next slide. So if you look at all these other things, the PXE boot, the network boots, the ability to apply configurations and the security problems around them, if we could even convey those, FDO actually has a unique set of capabilities here that we can now say, well, wait a minute, if we have a system where we can late bind and describe to an endpoint who its owner is, that also means that if we use that primitive and we want to apply a configuration to that system, we can use that concept of late bound proven ownership to not just give the endpoint the information, this is how you should be installed and this is how your configuration is, but we can prove that actually came from its deemed end owner, even though that was unknown at the time it left in the manufacturing process. So we can build an endpoint, we can ship it out, and then we can late bind and prove who its owner is and that the owner has requested that the system be installed in the specific manner. Okay, so now go to the next slide. So the idea is if you just, and this is a high level concept, if you just look at the existing pieces out there, Pixie has problems. What are the problems with Pixie? Well, it relies on this trust of the network. So it means that you have to have administrative controls over the network. It obviously isn't going to work on a cloud because a cloud is going to be an open network and you're not going to really have controls. It's going to know where to go. Things like HTTP boot, you need a user to point to the user at something. So A, it's not zero touch, and B, you're implying whoever's sitting there giving it that URL, has the authority to tell it what's installed on that system. So the long story short, and I will, basically stop my talk here and open it up for discussion and questions, is that if we think that FDO has this ability to provably give a system or provide a system proof of who an owner is, and then the idea that the owner has signed off on this manifest or configuration of what you should be installing on the system and how it should be configured, that this concept of the signed ownership voucher and the configuration could be used and extended by existing tools in the process, as long as these tools become aware of it. For example, I can give or allow to get this voucher to a system and have the system prove it came from owner and prove that this is the image and the checksum it should be running. Standard Pixie, iPixie, HET boot, or whatever can then go and execute that. Now that image is verified and executes. Now it needs to know how to configure itself. If you can use that same, information and that same voucher with the same proofs and signatures, whether that's in something like a Kickstart config or a Cloud Init or whatever the format is, but now you have a way of signing that, of proving where it came from, and allowing that installer image to introspect, not just to take something like a blind Kickstart file, but to introspect and prove that, oh yes, this really came from the valid owner, we can trace it back, and then to have that applied into building the system image. So there's a few little gaps in this, obviously. We need some FDO awareness in different pieces. These kind of magical arrows in which this ownership voucher can be conveyed amongst these different steps needs to be, worked out inside these images. But this is at least kind of a straw man idea of saying how we can apply the concept of an ownership voucher to rigidly prove and allow a system to be instructed and configured how to install using existing methods and not kind of rewriting the wheel. So this is, yeah, so I just kind of wanted to open up to questions and stuff, and to say that this is something that's very fluid. It's something that we are encouraging and soliciting other people's input and feedback on this if they think that this is an area that's important to dig into.
So Peter, guys, thoughts?
Yeah, I mean, ultimately, this is something that I've been pushing for in FIDO for as long as I've been involved. So, like, overall, the concept is absolutely what I want. Yeah, there's some nuances and sort of detail into it. But yeah, I think absolutely this is needed. And it will fill out, I think, FIDO and help make it a standard that's even more useful than it already is.
Great. Are there any thoughts in your mind that things that we really need to be thinking about? And obviously there's going to be in-depth discussions, but just sort of, are there any red flags, things that you really feel that need to be thought through when we start defining this? Because 1.2 is almost out the door. So it feels like the time is right to start moving the conversation over to really defining BMO.
Yeah, I see things like Pixie and iPixie up there, and it's like, no, like it should be things like HTTP, like generic stuff. But that's implementation details. I think the concept I always had was the device powers on, I don't have an OS. I reach out using the FIDO protocol, authenticate myself, and say I'm pre-provisioning, I need an OS. FIDO returns over that, authenticated link, a provisioning URL like HTTP sort of thing. And so that's all verification. And if you need like an authentication token to get access to the installer, like things like that can be provided as part of that URL. And then it obviously just goes away and uses the device's standard way of provisioning. So in the case of an average Linux Windows system, that's, HTTP boot. So using existing technologies without reinventing the wheel, it goes off and provisions itself. You should be at that point using a generic OS. So I don't think dealing with a huge amount of config at that point makes a lot of sense, because you're just making things more complicated. Because you can then do the rest of that configuration as stage 2 using the existing like bindings. So I think very much keep it as simple as possible. Like, don't overcomplicate the problem.
Don't over-ice it.
Yeah. And ultimately, if people want to do things like early configuration, that should be done as part of the provisioning process that the OS deals with themselves. And you can pass, it could be like a client certificate down as part of that. But again, I would generally do that as part of the late onboarding, as opposed to like keep the BMO, just enough provisioning, and make use of existing. And like if it's a much smaller device that's like running an RTOS or something like that, you can still use a standard HTTP protocol, because most of those will use, REST or something like that with firmware, specific firmwares for a device. So like by keeping the provisioning essentially URL as HTTP, you're abstracting away the implementation details for the the client,
The user, to sort that out.
Yeah.
Leave it to them. Leave it to them. Thank you.
So yeah, that's like, and like one of the other things you could do as part of BMO, if you're running in the firmware context, and there is security implications to this, so I expect people like yourself to have an opinion here. But if we're running in a firmware context, you could do things like, potentially do things like provisioning of secure boot keys, because you've got an authenticated secure channel that could potentially be used to add secure boot keys to UEFI firmware. I don't know what that looks like. That's just another dumb idea I've had, and would like security people to tear that to pieces. But you know, there is the potential of things like that, because provisioning things like secure boot keys to a device is a problem that isn't solved yet, but has a potential to possibly be done here as well.
Okay, so it'd be added value, effectively being able to do that in addition to get those boot keys
Over a
delivered.
secure authenticated channel.
Yeah.
Because like a lot of companies want to not trust the Microsoft keys and import their own keys. But at the moment, if you do that, you can use things like the machine operator key, but that needs human input of a yes, I accept these keys. And you know, in a data center where things are in a rack and you've got warm hands, that's a possibility. But even then, it's not a simple thing to solve. If it's out on the edge, it's impossible, because who do you trust, etc.
Right.
And so you've got this trusted channel with authentication and everything that could potentially, but that's, I think, a slightly different problem to solve. But it's also that pre-provisioning, like needs to run in like a firmware context to be able to accept those keys, because otherwise you've got to use mock, and that needs human input. So that may be something we could solve here as well. That would also add value. But
So
I would like Joachim to tear that to pieces.
Yeah. Okay.
So I do want to interject, because Dell Native Edge deals with this exact problem. Dell Native Edge endpoints do not have Microsoft keys. We kick all the keys out of the platform except for our own, and we sign our own code images. And so the idea, and this is, if you look at this diagram, it actually indicates it. But the idea is, say you had this system that had no secure boot keys in it whatsoever, i.e. it can't boot anything, and secure boot is on, for example. If this system were to run this early FDO, and you can even see in this diagram, the ownership voucher in this context has this little config block. But if that config block actually had a secure boot key, that could mean that in receiving this ownership voucher, it tells this early FDO component, for example, I am your owner, I am proving that I am your owner, and I'm proving that as your owner, I request you to install this secure boot key. And so now you have this attestation back all the way from the manufacturer, extending to the owner, extending to the owner's desire to install the secure boot key, and then sort of, so this config concept becomes, okay, and the next concept is, and here's the image I want you to install. Now it can go off and install it. Of course, it means this installer image has to be signed by that secure boot key, and then it carries forward again into, okay, now we're installed. Now the installer image, if it is smart enough, can introspect the same OV, recognize it's valid, recognize it goes back to its real owner, and oh, I need to now install this SSH key. And then when it does that, that means it's okay, now it's installed, it's on its network, it's secured, it's running the secured OS, it has a secure boot keys, and now I can log into it because it has an SSH key or whatever on it that can be traced back either at installation time or subsequently to be proven that these are requests that trace back to the owner who is mandated the system be installed as such. And it also means if you wiped this system out and did push the factory reset button, you wouldn't be able to crack into the box or anything, because you'd now revert it back to secure boot with no keys installed and required to go back through the installation process, which should deterministically bringing it back into the same state and security state which you initially intended through this late bound specification inside the ownership voucher.
Thanks, Brad. Joachim, any comments?
Been thinking about a few things. I mean, we have our people in the room as well. I mean, system ready and things like that, which is about trying to boot up any distro basically independent of how it's like. And that seems to be one way how you could use something like this as well. If you have a BMO and you have it kind of system ready, done, then you should be able to build something like this, and you can basically pick whatever it's going to look like.
I think that leads rather to Brad's picture, the any OS to any device to any vendor.
Yeah, that's
And the desire here is, hypothetically, say we said, okay, we're going to put this early FDO component into system firmware. Theoretically, what that means, or what we're driving at, is if any system is built to these specifications, and any distribution is meant to allow themselves to be configured by these means, introspection of an ownership voucher, which is put in there. The goal here is for you to have this cross ubiquity between devices that come from many vendors built in a certain way with these core capabilities, operating systems that know how to not just install themselves, but do this extra little bit of a tested configuration, built largely upon pre-existing mechanisms. So now you have this concept of any device goes to any one of these operating systems, user configuration applies, and you're always, regardless of which components you're picking and choosing, are allowed to ultimately come up with this very deterministic user specified operating system or operating environment in the end.
Yeah, I mean, ultimately, like with regard to user config, I think you want to do just enough user config to get it into a management platform and let the management platform deal with the nitty-gritty details. Because I don't think because FIDO is essentially a run once protocol, you want to do enough config to say get a client side certificate in place, registered into a management platform, and let the management platform do the vast majority of that config. Because this isn't a config management platform. You want it to do just enough config to be able to, if it's create a user, deploy keys, etc. I don't think it makes sense for FIDO to become a manage everything sort of thing, if that makes sense.
Yeah, so it makes.
I'm sorry, I should mention one more feature that we didn't cover is that when you finish the transfer ownership 2 protocol, you actually get new FIDO credentials to run FIDO in a different context. So
Yeah.
you can actually run FDO and then have that segue into a different context and run FDO again. I'm sorry, Brad, go on.
So yeah, I was just going to say, so my goal here, actually, can you go back? What is it? One slide. So the idea here is that we don't want to rewrite the world. We don't want to specify the way that a system can and should be configured. But it's more so if we already have mechanisms like Kickstart, like Cloud Init, mechanisms which we can specify a configuration file or set up to a system, we don't want to say we should be rewriting these things. But what I think we should be doing is, instead of saying, let's leave these mechanisms in place, but wrap them in the context of something like an ownership voucher. So rather than just saying, here's a Kickstart file, go do that, we can prove that that configuration has been mandated by the intended late bound owner of this platform. And then we actually have a way of introducing that ownership voucher, including that configuration in there. So existing mechanisms like Kickstarter, Cloud Init, let them do what they do, but let's just kind of wrap it with the security and zero touch pieces. The transference through the ownership voucher, the provenance through the ownership voucher that FDO provides. That's really what we're kind of thinking or proposing here.
Yeah, I don't see why you couldn't provide that as part of provisioning URL and let the provisioning platform just deal with that itself.
You could, if you A, stood up a separate provisioning platform, B, had a way to specify that URL in a provable way that it came from the owner, and then to specify, either the security posture around access to that URL or the signature on the payload that came from the URL. But how do you attest the provenance of that through the process and not require other additional network infrastructure? Because it might be as simple as, I want to install Windows on this box, something as simple as that.
But if you're installing Windows on the box, you need, provisioning infrastructure, whether it's a web service or whatever anyway.
Well, it could just be grab it from, Microsoft's ISO and install it. I might not have an on-site special like Puppet or Chef or Ansible, orchestrator that I'm going to do. It might be that this is just, a box that I just want to install a standard OS directly from a distributor, and I don't necessarily. So like I could with not necessarily with a Pixie boot, but maybe like an HTTP boot. So I don't have to stand up custom infrastructure on a premise or custom infrastructure in a cloud just to kind of do some rote installation of standard operating systems, themselves.
Yeah, but I mean, you can still do that via a standard web service and a provisioning URL.
Yeah, I mean, provisioning URL, just you need a way to say, how do you know that? How have you proven that URL is valid? It came from the intended owner, or the contents that came from that is equally valid.
Because you would pass it as the provisioning URL over the FIDO protocol, but like, how do you prove an ISO, like a standard ISO is from, like, it's the same, like, it's a similar problem.
You're saying that if the secure channel is used to give the command in the direction, then it's, it should be kosher kind of thing,
Yeah,
right?
it's authentic.
You know where it's authentic, you know where it came from.
It may be wrong, but at least you know who told you.
I think, passing something like a Kickstart down is very specific, and you need to know specific things about how to pass that into an ISO and stuff like that. And I don't think we should be dealing with that, because otherwise we'll essentially in the client have an if else of 100 lanes. So like but like, I think that's details that we can
It's a working group discussion, right? That's the purpose
Absolutely.
of the working group.
And then, so I think, we're close enough that we're in agreement that it is the right thing to do. And, there's minor details to be sorted out. So I don't think we need to spend a lot more time here.
All right, fantastic. So with that, I'm going to call time on that if you're okay, Joachim. Is that okay? I look to you to.
Yeah, we can definitely continue. I think I had one comment about this.
Please.
And it's however we actually get whatever image we download, where we get it from. At some point, we're going to reboot the device, and then we're going to have like a secure boot or some sort of measure boot or attestation involved of some sort. So the question is whether it's risky to kind of install the wrong image, but you will eventually catch it when you reboot or something like that, and what kind of implications that would have. So at some point, you will figure out whether you're running the correct image anyway, I guess. So
Right.
You could be using FDO as a rescue partition, right? You could be saying that there's a base partition that runs FDO when you boot the device the first time. And I won't comment on what base software that boots up, but it boots up some software you trust. And then and that partition stays there, and you install around it, so that you can then use that as a trust mechanism. And when the FDO's replacement credentials stayed in that partition, so that you can then say, yes, if I have to, I'll reboot through that trusted partition, I'll go back to base, and I'll reinstall whatever I need. I'll bootstrap my way back up. So that would be one way that you could think about that.
Yeah, there's pros and cons to that. One, being another OS sitting there, it needs to be managed and patched. And
yes.
CVE'd and things like that.
But it could be simpler. But yes, I agree.
And if the disk fails, for example, and a new disk is shipped out, how do you then recover it, because you don't have it on that disk necessarily?
Yes.
So there are nuances to that as well.
Yeah. Okay.
Yeah. So we've actually had, because Native Edge basically does all this, and so for example, what do you do about the blank replacement disk as one? What do you do about needing to patch that quote unquote, we call it a factory OS? But the greater problem is, how do you then go and run a Windows installer or a operating system X installer when those installers by default will often try to take over and repartition and wipe out the whole disk, and that might include wiping out the components that you put on there. So the problem that we've run into is we can do that, but now we have to do it only in the context of operating systems whose installers are aware that there's this other operating system that they shouldn't be wiping out, and when they start installing bootloaders, to know that they have to leave a boot option for this kind of factory installer in there. So the long story short of it is that's why we feel it's important that this stuff kind of gets pushed maybe more towards the firmware side, because it's very hard to allow generic operating systems to play well with on disk components that are actually responsible for some of this stuff without
Agreed.
wiping them out and destroying them.
Well, agree, and also you then have other issues like if the customer blows away the secure boot keys, how do you verify that OS?
Exactly, right, exactly. Yep.
That I'm aware of customers that are like, if that's extra OS and it's not actively managed, I don't want it anywhere near the device because it becomes an attack vector.
Yeah.
So there's things like that where I think putting little OSs on disk for recovery almost causes more problems than they solve.
I 100% agree. They're nice, but you can't rely. They're nice and handy if you can use them, but you have to prepare for what happens if you can't use them.